Hello and welcome. This is a lesson on measuring air pressure. Get ready to learn. We're going to find out what this thing is. Did you know air is made of matter and takes up space? Air molecules are attracted to Earth by gravity, just like everything else is. Air exerts pressure on everything. And the pressure varies, changes by temperature and altitude, how far above the Earth you are. And air pressure can be measured. Why is this important? We can determine elevation, knowing air pressure, how high we are off the ground or off sea level. The difference in air pressure makes wind. Water and land don't heat at the same speed. So there's difference in air temperature, and air temperature causes a change in air pressure. And the difference in pressure, the balancing out, air moving from one place to another, we call that wind. And we can float in the air the same way you can float in the water. It's just a gas instead of a liquid. What's important to know about air pressure? Well, knowing about air pressure lets us predict the weather. Not exactly predicting 100%, but we can get a good guess. Lower air pressure means a greater chance for rain. Lower air pressure means that there's more room for water molecules. Higher the air pressure means clear skies. So when you have high air pressure, you don't have a lot of room for water molecules. Not a lot of water molecules, you don't get clouds. So you get clear skies. Okay. This is an altimeter. Same base word as altitude. Knowing about air pressure lets us fly a plane safely. This changes air pressure into distance above sea level. The lower the air pressure, the higher you are in a plane. Well, think about it. Most of the air molecules are near the ground. And as you go away from the ground towards space, out in space, there's no air molecules, or very, very few. So the lower the air pressure, the further you are away from the ground. And the higher the air pressure, the lower you are in a plane. And it's important to know how high you are above the ground if you're flying. Okay, air pressure. The measure of the force of a column of air molecules that is stacked up around 100 miles into space. Let's see what this is talking about here. This is atmospheric pressure, and this is distance from the ground. It's a little different graph than you might be used to seeing. Here's Mount Everest. So if you're on the ground here, you have the highest air pressure. As you go up in altitude, air pressure goes down. That makes sense. Pressure is due to gravity acting on a stack of molecules. If you had a column of air, 1 inch by 1 inch, and you had a column going up from ground level or sea level into space, all the air in there that is stacked up would weigh, if you put it on a scale, a little under 15 pounds. And that's where we get 15 pounds per square inch from. So here at ground level, you got the maximum air pressure. And as you go up, makes sense, there's less and less above you pulling down or attracted to the Earth's gravity. Now, we can measure that. There's a couple of different ways. Air pressure is 1 kilogram per cubic centimeter, that's in metric, or 14.76 pounds per square inch. Now at sea level, nearly a ton of air is pressing on you. Take the number of square inches on your body. Got nearly a ton. You can sometimes feel the changes in air pressure when you're going up a mountain or taking off in an airplane. You can feel it on your inner ears. You have to chew gum or yawn to balance out the air pressure. And it's measured, air pressure is measured with something called a barometer. Baro, meaning pressure, meter. So this is how this thing works. We have, see if I can draw here. We have a box. Think of it as two garbage can lids that are sealed. The higher the air pressure, the more it's going to squeeze that. The lower the air pressure, the less it's going to squeeze it. And then through levers and cables, this dial moves back and forth based on how much this box is squeezed because of air pressure. Now, varies from place to place. Changes in air pressure. It depends on two things, temperature and altitude. Let's go back. This is a graph of pressure. So increased altitude means lower pressure. Think about it. If you're on the surface, you're at the most pressure, and if you're out in space, you're at 0. We can measure air pressure. It's in usually pounds per square inch. Normally PSI, it's abbreviated. And you can measure it with a meter. This is for measuring the air in your tires. So air pressure at sea level is about 14.7 pounds per square inch. Of course, it varies with temperature. But at sea level, it's not going to vary with altitude. But if you're out in space, 0. That's why we need a protective spacesuit to keep the air pressure around us. It's not the same 14.7. It's usually somewhere around 3 to 4 psi. So it's a lot lower. Otherwise, you would blow this up like a balloon and not be able to move. Why aren't we crushed by air pressure? Well, a couple of reasons. People like you and me are usually made out of mostly water. And water you can't compress easily. And air presses on all parts of our bodies, the top, the bottom, the left, the right, the front, the back. So it's balanced out. We don't feel it. Now, if you go to outer space and you don't have a spacesuit on, you're going to feel it. Okay, we have a weather map here. We have high air pressure and water vapor. Remember, we talked about high air pressure meaning clear skies. You usually have a letter H where the high air pressure is. And that's usually clear skies. You'll notice it's not where the fronts are. Air molecules are mixed with water vapor, but high pressure holds only a small amount of water vapor. Now, low pressure, air molecules, again, are mixed with water vapor, but low pressure holds a higher amount of water vapor. There's more room for the water to be in the mix. So these lows bring precipitation. They're usually along the fronts where the high and the low meet up. Water in the air. Air molecules are mixed with water vapor. But here's the thing. Water vapor is invisible. It's a gas. So clouds, if you can see them, that means it's not water vapor. So clouds are actually small frozen droplets held in the air by wind. Where they are in the atmosphere is very high up, so it's very cold. So it just makes sense. Why is this important? We can determine elevation knowing air pressure. The difference in air pressure makes wind. And we can float in the air. That's why it's important to study air pressure. Here's your lesson in measuring air pressure.